Hello, this is the day after. The soap is now setting, as you can see. If I tip it up, it only very slowly moves around, although it will take a while to get used to, or rather to get hard enough to be a proper bar of soap. It is softer, and as I said, it's made of almond oil. I wanted to cover today the scientific stuff that you can get out of soap making. This has actually got quite useful. It teaches a lot of different scientific aspects. First of all, you have the issue of sodium hydroxide being an alkali. Sodium hydroxide is in fact very alkaline. It's the most alkaline substance known, I think. An alkali is a substance which, when you put it in water, releases hydroxyl ions. That is, hydrogen and oxygen joined together and charged. The reason sodium hydroxide does this is because it is sodium joined onto a hydroxyl ion. This makes it alkaline. Now, with both alkalis and acids, it's dangerous to put water onto them rather than the other way around. If you put water onto a strong alkali or acid, it will cause what's known as an exothermic reaction. That's the reaction that releases heat. If you put a small quantity of water, effectively, onto a larger quantity of the acid or the alkaline, that will cause it to boil, and then it will spit, and that spit will contain either the alkali or the acid. And they're very dangerous if they're strong, and sodium hydroxide is one of the strongest. I'm wanting to put a picture in here of a picture of a burn. This is a picture of a sodium hydroxide burn on the back of someone's hand. This is actually only something like a 5% sodium hydroxide solution, so you can see that it's important to wear gloves when you're doing it. Okay, another thing that comes up with this is the solubility. Sodium hydroxide is much more soluble than salt. If you remember back to the previous video, I actually added only slightly less sodium hydroxide than I did water when I put them together, and yet it completely dissolved. And in fact, I think you can go beyond the weight of water with the sodium hydroxide, and still all of it will dissolve. So you'll end up with a very powerful sodium hydroxide solution that you shouldn't touch. Then there's the question of molarity. Now, the best way to think of a mole, I think, is just to think of it as a number, which is 6 followed by 23 zeros. Basically, it's a very large number, what I would normally have called 600,000 trillion, which in the short scale, which is the more popular scale nowadays, is something like 6 quintillion. The reason for this number is that it's the same number of particles as there are atoms of carbon in a pure sample of 12 grams of carbon-12. And the importance of the number is that it enables you to match things up. So if you have, for example, 2 moles of oxygen and 4 moles of hydrogen, both molecules, then you'll be able to make water with that with nothing left over. In the case of sap values, these are the values that match the sodium ions to the fatty acids in the oil. Now, there should now be a diagram of a triglyceride. This is a molecule of natural oil or fat. It consists of 1 molecule of glycerol, which is glycerine, which is a carbohydrate, which is a roughly E-shaped molecule, and then onto each leg or arm of the E there is a fatty acid molecule joined. So there are 3 fatty acids, a triglyceride, and the job of soap making is to separate those 3 fatty acids from the E on one side and replace that with sodium on each. So that will make 3 molecules of soap. This will then make the soap molecule run away from water on one side and attract itself to water on the other side. And the same applies to fat. Now, there are different kinds of fatty acids. Some of them are longer than others, some are heavier than others, and so forth. As a result of this, each fat has different sap values. In the case of almond oil, which is the one that I used yesterday, the sap value is 13.7. If you use sodium hydroxide, that's how much you need. If you use potassium hydroxide, because potassium is slightly heavier than sodium in terms of the atom, the SAT value will be slightly higher, it will be 40% higher. Now, the way soap works, each soap molecule has one end that is attracted to water and one end that is pushed away from water. Water itself consists of molecules which are charged oppositely at one end, and because opposites attract, the water molecules tend to stick together. Because they stick together, they tend to form a skin on the surface which is difficult to penetrate because they're pulling themselves together and trying to avoid letting other things in. When you add soap to something, it reduces the tendency of the water to do this because of the charges on the soap molecule. This basically makes the water wetter. If you put soap into water, you will find that it is less sticky. The water is less sticky than it was. Because it makes it wetter, it makes it easier to wash. Another thing it does is soap will tend to form into things called micelles. You should be seeing a picture of a micelle now. This is what happens when you put a fat or an oil in water and it gets into the water, and then the soap tends to surround it and you end up with a little bubble which is pulling the fat away from the surface. So to the extent that there is grease or whatever on something, it will basically dissolve the grease, although it doesn't in fact dissolve it. This also happens inside the digestive system and makes fats easier to dissolve and easier to digest there. One more point, I'm just going to do a little bit of financial calculations here. The 500 grams of sodium hydroxide that I bought cost me £2.13. I needed 68 grams of that to make almond oil soap, 500 grams of almond oil soap, so that's half a kilo of almond oil soap. Works out at 27p, provided you don't take the almond oil itself into consideration. Now, if you are using spent cooking oil, for example olive oil, which makes a particularly good soap, and it will have a different SAT value, that means basically that you can make half a kilo of soap for 27p. This soap will be slightly greasier, it will be slightly softer because it's particularly pure. It will also continue to contain glycerine. Now the glycerine can be removed, but it is actually quite a good thing to have in it anyway, so it's better to leave it in. So that's it. That's covering all the science that I want to talk about soap today, and hopefully I'm going to manage to insert some diagrams into this video, otherwise it's going to be a bit abstract and weird. Goodbye.